Honorable Parliamentarians, Honorable State Assemblymen, Your Excellencies, Ambassadors and High Commissioners, Tan Sri, Datuk, Fellows of the Academy of Sciences Malaysia, and Professors from the National Professors Council, friends from the media, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. I'm Nuraini, your MC for this morning. I would like to extend a warm welcome to everyone for your presence this morning at the International Symposium on Rare Earth, Moving Malaysia's Green Economy Forward, organized by the Academy of Sciences Malaysia. As we know, Malaysia is stated to have some 0.03% of global world reserve of rare earth minerals. Lynas Corporation helped build their advanced material plant at Kuantan, Pahang, for rare earth mineral processing using processed ore from Mount Well, Australia. This project had resulted in protests from various sectors of the public with fears of environmental, safety and health issues being raised. It is believed that these fears arose from lack of accurate scientific information available to the public on rare earth in general. The process involved and the measures that can be taken to safeguard the environment, safety and health of not just the workers in the plant, but also the general populace around Gebeng. Today's symposium will provide the latest information on rare earth upstream and downstream status, address safety, health and environmental issues concerning rare earth, and provide a platform for rare earth experts to give a global supply and demand perspective to rare earth and their many applications. Currently, the global demand for rare earth can provide myriad business opportunities in Malaysia, utilizing rare earth for green technologies industries. Without further ado, we would now like to invite Yang Berbahagia Academician Dato' IR Ahmad Zaidi Laidin, Council Member and Senior Fellow of the Academy of Sciences Malaysia, to deliver his welcoming address. Dipersilakan Yang Berbahagia Dato'.
Bismillahirrahmanirrahim. Yang berhormat Ahli Dewan Rakyat, yang berhormat Ahli Dewan Negeri, Dewan Undangan Negeri. Kami di Akademi Sains ni jarang dapat undangan atau terima pengunjungan daripada yang berhormat. So this is actually a great opportunity for us to interact with the members of Parliament and State Assemblies. Excellencies, distinguished guests, distinguished speakers, ladies and gentlemen, Assalamualaikum warahmatullahi wabarakatuh, and a very good morning. It is actually my pleasant duty this morning to bid you welcome. In fact, I was instructed to give you a warm welcome on a very hot topic. And we realized last night, we had a dinner, that this topic is not only hot in Malaysia, but it is also hot internationally. And because of that, this morning, we don't really have dignitaries to come here. We have less formality that is customary to Malaysian symposia and conferences. So instead of having a minister, you're having a little retiree like myself to greet you welcome. But in any case, it is actually a great honor and privilege on behalf of the organizing committee to bid you all welcome this morning. Ladies and gentlemen, first of all, I am glad to see so many people who are very much more acquainted with the subject than I am. But at the same time, we, of course, were hoping for a few more people to come. But as we know, rain normally, plus the traffic jam, will deter a few people from coming on time. Nevertheless, the show must go on. I would like, first of all, to say a few words about the Academy of Sciences for those who are less familiar. Because the Academy of Sciences Malaysia, or Academy of Science Malaysia, is only 16 years old. We were established by an Act of Parliament in 1995 and launched in 1996 with only 50 foundation fellows. And from year to year, this has grown, and at the last annual general meeting, we have 225 fellows. It's really quite a small number. And they come from 6 disciplines. And as far as we're concerned, however, we pattern ourselves after the Royal Society of London. But for the record, the oldest Academy of Sciences in the world is Leopoldina Academy of Science in Germany. They already are 360 years old, and a good 8 years older than the Royal Society. Now, we in Malaysia are fortunate to be a member of the Inter-Academy Panel. This is a network of academies of sciences in the world, 104, divided into developed and developing countries. So we have 2 co-chairs, one representing developing countries and the other representing the developed countries. Now, whether developing or developed countries, the academies of sciences in the world share a few common ideals. It is important for me to state this because one of which is it has to be merit-based. What it means is that you can't apply to become a fellow of the academy. It is your peers and others who should put your name up to say that yes, you are suitable to become an academy fellow. And secondly, although we are elected by an Act of Parliament, we are expected to be independent. In other words, we will give our views to all and sundry, particularly to the government, without fear or favor. So sometimes we may not be very popular with the government, but it is because we adhere to the values of the academies of sciences in the world that we have to have this particular stand. But of course, that is not an excuse for us not having a logo on this thing. It's not that we are scared of saying that we are Academy of Sciences. The logo is actually on the sides, as you can see. Ladies and gentlemen, first, why did we get into this particular subject? Well, in late 2010 and 2011, the Academy noted with concern on the large number of objections from members of the public on the proposed Lynas Advanced Materials plant that has been constructed at Gebeng Industrial Estate in Pahang to process the concentrates from rare earth concentrate ore from the Mount Weld, as it's mentioned earlier, from Western Australia. The Academy decided to form a working group. And this Joint Rare Earth Working Group, with members of the National Professors Council, came out with a report, and I think you all have been given a copy. If you have not, I think there are a few copies outside that's still available. Now, the working group, when we were into it, discovered that rare earth elements were used in a vast variety of modern green technology, such as in wind turbines. We found out that the magnets in the green turbine actually have additives from rare earths. But as I was reminded yesterday, by Jack Lifton that rare earth is not one element, but there are 17 different elements, and not all sources of rare earths have got all the 17 elements. Consequently, it depends very much on your sources of ore and the contents of those elements. But having said that, it is clear there's a wide variety of products that contributes towards green technology that come from these rare earth elements. That includes hybrid cars, lighting, and so on. And consequently, it is also in line with Malaysia's stand on climate change through the reduction of the greenhouse gases. And this commitment was made by our Prime Minister in Copenhagen not so long ago. So, ladies and gentlemen, the working group was mandated to look into the science behind rare earths, the processing and refinement of the ores, the environmental, safety and health concerns, as well as the potential downstream industries, which Malaysia could leverage on with the presence of this plant in Pahang. And therefore, when the working group produced this report, we have to be very careful that we look into other reports, particularly the IAEA reports, that we found to be extremely professional and instructive, and made several recommendations that we will hope, and not only hope, we expect that the government to adhere to. Incidentally, I also see some very big guns in this room. Datuk Raja is also here. And I'm delighted, although perhaps we have not really fully filled this hall, but we have quality people attending it. Ladies and gentlemen, this report, incidentally, is published in 3 languages, in English, of course, also in Bahasa Malaysia, and in Mandarin. Now, I do hope and wish that each and every one of you will take back with you these copies, and because we believe this is one way to reach out to our audience. Now, the working group is of the opinion that Malaysia could benefit from the escalating demand for rare earths in this emerging high-tech business. And although we are told that at the moment China controls 95% of the world market, but we also are aware there are so many plants that are about to take off or people are interested in. However, we believe, as far as Malaysia is concerned, that we have recommended the following 7 strategies. First, enhance the environment, safety and health aspects of the management of industrial estates, not only in Gebeng, but all other industrial estates we have in Malaysia, especially those which host environmentally high-risk industries. Second, to undertake a national exercise to map the potential rare earths, alluvial and hard rock deposits, as well as evaluate their economic potential. In this respect, we are also suggesting that Malaysia re-look at not only rare earths, but all other minerals that Malaysia has. Third, incentivize the upstream mining and extraction of rare earths through partnership with global enterprises which have access to technology, market, and finance. And indeed, you'll notice that 2 of our speakers are very much in this field, and they are very experienced, and I can assure you they're also very critical. I'm not sure what they're going to say, so I'm as excited as you. Fourth, we look at the investments in downstream manufacturing of rare earth-based products to target the export market as well as the substitute imports. Fifth, to build key competence in human capital for the entire value chain of the rare earths business, including processing, refining, manufacturing, logistics, and other services. Sixth, strengthen the legal and regulatory framework to enable the effective functioning of the rare earths business without compromising on the safety and health of the people and environment. And 7, undertake a coordinated, comprehensive, continual public awareness program and pursue regular engagement with the community on the risks and opportunities of new technology-based business. It is actually part of the last strategy of public awareness and engagement with the community that we have organized this international symposium, where we've invited the 4 international experts and 1 local expert to provide a first-hand view of rare earths and related issues. And as I have already mentioned earlier on about Mr. Jack Lifton, he is going to give us the keynote speech. He is from the Technology Metals Research in the USA and has been in the business for the last 50 years. The next is Professor Chun Hua Yen, and he hails from Peking University. Those in the academia would know the ranking of Peking University in the world of universities. And he himself is the chief scientist on rare earth functional materials at this university. Next is Mr. Alistair Neil from Dacha Strategic Metals, and he has positioned himself in China presently, but he has also been in the business for many years. And next we have Mr. Christoph Wilhelm from Karlsruhe Institute of Technology, Germany. Now he is very familiar with matters relating to radiation. And incidentally, I myself had the chance of studying in that particular institute some years ago, before it was merged into the Institute of Technology. It was a separate IAEA training center. And I can assure you that they have done a lot of work with a lot of experience on radiation and technology. And finally, our own Dr. Yusuf Mio Sulaiman from Malaysian Nuclear Agency. And he is going to talk about the Asian rare earths experience that has been referred to so very often by all and sundry in Malaysia. And we will see how and what steps are taken to look at this particular industry. Ladies and gentlemen, the CVs are available in the program, and I really would like to convey our sincere appreciation to all the speakers for consenting to come to Malaysia and participate in our international symposium. We gave them very short notice, and we were really surprised that they could come in spite of their, I'm sure, commitments elsewhere. They will therefore address on safety, health issues concerning rare earths, including providing the platform for international rare earth experts to give that supply and demand perspective. I understand that it's growing at the rate of about 60 to 70% per year, and then we will see what and how this is going to impact upon the world of rare earths. Ladies and gentlemen, this afternoon, please come back for this afternoon's discussion, because the panel discussion to be moderated by academician Datuk Lee Yi Cheong, entitled "Should Malaysia Invest in Rare Earths?" And I know there are many sides to this story, but I'm sure you'll find it to be a very absorbing and interesting topic. Finally, I would like to take this opportunity to thank each and every one of you. And there are those of you I know who had come from overseas. I've met somebody from Turkey and India, and I understand there's also from Australia who are here today at their own cost, I might add. And that shows that it is really more international than we initially thought of. We stamped it as international symposium because we had international speakers. But now, in the midst, we also have international participants. So, ladies and gentlemen, I think I have spoken long enough. I would like to finally say thank you so much for coming here this morning to share with us this, what will prove to be a very interesting morning and afternoon. And I also would like to welcome again the members of the press who are here, as well as the NGOs. And I've seen Dr. McCoy earlier on, a very outspoken critique, but we welcome them, because here is a time and place where we can actually engage with international experts. So with that, all I have to do is to bid all of you once again to have a very fruitful symposium this morning. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Thank you, Yang Berbahagia Dato'. Ladies and gentlemen, we would now like to invite Mr. Jack Lifton, Founding Principal, Technology Metals Research, LLC, to deliver his keynote address on recent dynamics in the rare earth sector. Mr. Jack Lifton, if you please.
Thank you. This is my first visit to Malaysia, and I was saying to one of my colleagues that I'm from Detroit, which once was the automotive capital of the world, is no longer. I look out the window here, and I see more construction cranes just out the window of the hotel than I've seen in Michigan in the last 5 years. So this will tell you what's happening in the U.S. Having said that, I want to make a point. I have been working with rare earths, not continuously, but since 1962, when I had my first position, and I was asked to make a sample of pure neodymium. That was really a problem in those days. Okay. And today, I'd say for the last 7 years, I retired 12 years ago. I was the president of a chemical engineering firm. And 7 years ago, I decided why take it with me to the next world, whatever information I have. So I decided I would study. I have always been interested in rare metals, especially metals for electronic purposes. And so I was asked by an editor of a magazine to write a critique. And since then, I've written about 600 of them. And I have many clients as a consultant around the world, and I'm always excited when a new one calls me, and I say, which rare metals do we want to talk about? And they say, never mind rare metals, rare earths, that's all we care about. Okay, so that's the topic of the moment. Something has happened now. You need to understand. We have passed the age of exploration in rare earths. You may find more deposits. That's wonderful. There's a catalog on my website of 260 companies and 400 deposits. Okay, welcome to that list. It doesn't matter. We've entered phase 2 of the rare earth story, which is processing. Okay. We're embarking now on an adventure we don't know a lot about, because about 15 years ago, what was once the world's largest rare earth mine in Southern California shut down for various reasons. Most of them were economic, because China had been building its industry up and had reached the point where you could buy rare earths in Los Angeles, shipped from China, duty paid, for less than you could buy them in California, for the ones produced in California. This was the capitalist end of the game. Okay. 10 years later, that same mine, which was in 1984 the largest rare earth mine in the world, it produced some 60% of all the rare earths produced in 1984, which the official number was, in that year, was around 40,000 tons globally, and that mine produced 24,000 tons of rare earth contained in concentrate. In 2007, the mine was owned by an oil company, which had bought it not because of rare earths, they never heard of rare earths, they bought it because of its name, Molycorp. It was a molybdenum miner. Molybdenum is a very important metal in oil distribution, as I'm sure some of you know, because if you don't use high molybdenum steel in pipelines, they corrode and break down. So every mile of pipeline has about a ton of molybdenum contained. The oil company, at the time in America, it was the fashion to vertically integrate. You have to not blink your eyes. These fashions come in and out. And so they bought the company. Then they forgot about it. They decided it was cheaper to buy this stuff outside. Okay. Now that company has been bought by a private group, put back into operation, and I was told that 3 weeks ago they finally switched off the old original rare earth separation plant, which was built around 35 years ago by a gentleman who's still alive and retired, living in Mexico. And they're switching on the new one, which of course has never run before. So I have to make a brief comment as a chemical engineer. When someone tells me they're going to build a factory that they've never built before, I say, okay, good luck, but I'll try to make the opening, but I don't know if I'll be alive. It takes a long time to do something like that. So when they tell me not only will they do that, but build the world's largest plant ever of this type, I'm not a believer is what I'm trying to say. Enough about that. Okay. Now, I'm going to talk about rare earth markets where they are today. I'm not talking about politics, and there's no way I'm going to get into a discussion of chemical engineering with Professor Yan coming after me, who is the world's leading authority on the separation chemistry of rare earths. Okay. Now, if I can just figure out how to change this. Oh, yeah. Okay. This is being handed out, isn't it? Everybody gets a copy of this? Yes? Okay, good. Okay, because some of these slides are just pro forma. Forget that. If you want to know, I bought American Airlines stock in 1969 and lost my shirt. I never bought another share of any stock until 2 years ago. I bought some Great Western. If Great Western goes up by a factor of 10, I'll be able to buy a new hat. That's how much of a position I have. Okay? Okay. Now, if my old eyes can read this, I wrote this last night because I wanted to point out something. We're in a completely new era, and it's interesting to me when I talk to me, a young person is 40 years old. And I know that when I talk to 40-year-olds, they've never heard of the Beatles, okay? They have no idea the United States was involved in a war in Southeast Asia 50 years ago, and they don't care. I'm talking to America. That's wonderful. That's great. The real problem is they think that engineering and science can accomplish anything. This is, as we all know here, this is not true. When I think of the separation science of rare earths 50 years ago and 30 years ago, the difference today is not one of quality as much as quantity. And so I'm not certain that we're always going to be separating rare earths the way we do today, because we depend on enormous quantities of material being processed for very small gains. It's the only way we know how to do it. And I wanted to point out that, again, as was just said, there are 15 rare earths, atomic numbers 57 to 71. One of them, promethium, doesn't exist in nature anymore because its half-life it's been exhausted since the beginning of time. It has been seen and studied in nuclear reaction chemistry, but it doesn't matter. Of these 15 rare earths, I think perhaps 3, at most 5, are important. In fact, they're critical to modern technology. The problem with the rare earths is that they always occur all together in the same, in a deposit. Now, most deposits in the world are of the lower atomic numbered rare earths, which in the press becomes light rare earths. This is not about density. This is just about numerology. So the first 4 or 5 rare earths are the light rare earths. Some people have decided that after that they're called the middle rare earths and then the heavy rare earths. These are just arbitrary divisions by the atomic number, the number of protons in the nucleus. The important thing here is that no 2 rare earth deposits are the same. Most of the ones we have, the light rare earths predominate. They predominate to the point that of all the production of rare earths in the world, 50% is cerium, which is the rare earth with the least uses. It is the most produced. So when a businessman calculates the cost of producing a ton of rare earth, he has to pay for 500 kilo of cerium, which has no particular use. So right away, we have 50% left. Of that, of the total 1 ton, typically 25% is the metal, is the element lanthanum. Okay? Lanthanum has some uses, but I believe it's in surplus today because it doesn't have that many uses. Then we get to neodymium. And if we add cerium, lanthanum, and neodymium together, we're already at 80 or 85% of the known rare earths in the world. Those 3 elements. Of those 3 elements, however, neodymium is far more important than cerium and far more important than lanthanum, because neodymium is the basis of rare earth permanent magnets, which are the largest individual sector of high tech for rare earths. I don't remember now what oh yes, yeah. The reason I'm bringing up copper is I want to put, before I give you all this interesting or boring data about rare earth markets, I want to point out something to you about how they're positioned in the global market. This is a table I love. It's just a part table. Copper. We all know that without copper we don't need to worry about anything electronic, because we need copper to produce electricity and we need copper to bring electricity to devices made with copper to transform electricity into motion, heat, light, etc. Copper is the critical metal. Now, the point of copper is this. The world production of metals in 2011 was around 1.6 billion tons. 96% of that was iron. 96%. What percent was copper? Copper was 16 or 17 million tons, 1/10 of 1% of the global metal produced. So, what are metals about in our civilization? They're structural. These buildings are supported on skeletons of steel. Your roads have steel rods in them so the concrete won't shatter. Your cars are steel. Your refrigerator is steel. Steel is the key metal that you take for granted, and it's of course an alloy of iron and carbon and other metals. Copper, the most important metal to the civilization we have today. 1/10 of 1% of world production. Now, compared to rare earths, that's incredible. The total production of rare earths is 1% of the production of copper. So it's 1% of 1%. I think I might have an incorrect number of zeros in one of these, but the point I'm trying to make is that I'm interested in neodymium, the magnet metal, terbium, which is the most metal used in phosphors for fluorescent lamps, and dysprosium, which is an additive to neodymium alloys, allows them to cycle many times without losing their magnetic strength at high temperature. Look at the total percent of global production. For neodymium, it's 0.016%. Terbium is 1% of that, and dysprosium is a marvelous 5 times as much as the terbium. Believe this or not, the miniaturization of electronics, the fact that you depend on this high tech, okay, because you need to talk to everybody all of the time for some reason. Silence is no longer golden, okay? Without these metals, it would take two of us to lift one of these things. Or if any of you are old enough to remember the first mobile phones, we called them bricks. And they would tear you couldn't put them in your pocket unless you had a canvas pocket. Okay. Miniaturization is what rare earths have brought us. You can make loudspeakers, wherever they are in this room, as small as you like with neodymium iron boron ring magnets. When you made them with ferrite magnets, if any of you can remember that far back, we had home audio systems. The speaker was that size, the size of the podium. And we had to have our friends help us move it into the living room. Today, that same speaker is smaller than this, much smaller. Okay? That's because of rare earths. In a car, it's even more important because the actual legend, and it happens to be true, is this. In the late 70s, the designers of automobiles in Detroit decided that they were given the task of making, they called it thin doors. People didn't like big, heavy doors on cars. So the designers came back and said, can't do it. The smallest electric motor that runs the windows. Remember, Americans cannot accept a car without power, everything. When I talk to children under 40 about cranking a window in America, they say, this old man needs to go to the home. What's he talking about? Okay? Must be the 19th century. All right. So everybody has power windows. But the door was very big. And so when you swing this door open, it was very unsexy. It was like entering a safe at a bank. Okay, so somebody had an idea. He'd heard that samarium cobalt made a powerful, samarium, the rare earth samarium, and the metal cobalt, made a very powerful small magnet. It's true, okay. So they built some of these at General Motors, and they were marvelous because you could now have a thin door. And then somebody said, let's use this for the seat motor, and let's, the moon roof, and every other accessory you can imagine. Believe it or not, before electronic switching, a little motor was used to scan. When you push scan on your radio in the car, there was a little electric motor with a chain drive moving the tuning. So all this was wonderful, and then in 1984, geopolitics reared its ugly head. There was a revolution in the Congo. The price of cobalt went up a factor 10. So, in Detroit, when prices go up, you would think somebody died. Everybody is somber, glum, it's cutting into revenue and profit. They didn't want that. Well, what about this neodymium iron boron stuff? That looks promising, they said, and there's a lot of studies on it. Well, nobody had any. Luckily, this is when production of neodymium ramped up, actually for this reason. And it's never turned around. Today, this may surprise you, something like 70 to 90% of all the magnets on an automobile are neodymium iron boron rare earth permanent magnets. This is the large and growing market. Okay? Do not believe that the market is some exotic thing that you know, wow, look at that, it's used in space or something. It's used in your car when you, in this country, when you turn the air conditioner on, a rare earth permanent magnet motor is opening that port. Okay? Now, you have to believe what I'm going to tell you. Nobody in Detroit, Stuttgart, or Shanghai wants to replace rare earths with anything else. However, because of shareholders, the companies make announcements and they say, we are going to eliminate that. We're going to go back to ferrite magnets in our, they'll weigh another 100 kilo and they won't be very efficient, but we won't need rare earths. Of course, this is never, ever, ever going to happen. And even though the metal, the most critical metal is dysprosium. Total world production under 1,400 tons last year, 100% of that in China. This will also surprise you. The average speaker magnet, loudspeaker magnet, is 3% dysprosium. Now, people don't, they think, well, dysprosium would only be used in high heat situations. Yes, but there's something you overlook. The United States manufactures or sells this year 14 million cars. Those cars contain a total of 200 million loudspeakers. It doesn't take, now, the American production is approximately 20% of the world's production of cars. Multiply what I just said by 5, 1 billion loudspeakers just in cars. Now please add your phone. How many were made last year? I think about 1 billion. Loudspeakers. Oh, and this toy has a vibrating function. How do you think that's done? So the reason I'm saying this is that I keep hearing about, well, electric cars are going to be the big demand. No, actually electric cars are the problem. The demand is from normal cars, internal combustion powered cars. And although some few of you may be here in the world when electric cars get to 10% of the total, I don't know how many of you are under 3, you won't see electric cars in general, because an electric car just requires you burn a whole lot more fossil fuel to produce the electricity to generate it. They're too expensive. The batteries are not proven reliable. In the United States recently, we've had several fires and a rip-roaring explosion in Detroit of batteries under test. Now, I'm not saying that that is characteristic of batteries, of traction batteries. I'm just telling you that the public's perception is that these are not safe things. Plus, you can buy 2 Japanese Prius C's, the small one, for the price of 1 Chevrolet Volt. This is not a good situation for General Motors. Let's put it this way. The average internal combustion powered car on the planet uses 0.43 kilogram of rare earths. A pound. Okay, so, well, let's see. Of that, 63% is neodymium and 13% is dysprosium of that total. An electric car typically uses 7 times as much. How many cars and how many motor vehicles are there in the world? 750 million at the present time. Chinese car makers are predicting that in 2020 there'll be 1,200,000,000 cars on the road. So please understand that'll be 600 million kilo of rare earths tied up. They're not going anywhere. I mean, they're going from one stoplight to another, but they're not in the market. They're out of the market. Okay, you can do the calculations, and you can see immediately that if we start adding electric cars to the fleet, we're going to start ramping up the demand for rare earths, something fierce. And quite frankly, at the present time, we can't do it. So it's a huge problem. I'm going to give you a secret number. Don't tell anybody. One large American car maker I won't mention, which is the largest car maker, I won't mention their name, has calculated that in the year 2017, in their American operations, they'll need 170 tons of dysprosium at current use levels. If you multiply that, that company makes about 14% of the world's cars. If you multiply that then by 7, you get actually, just in the automobile industry, the total production of dysprosium last year. So what happens to new production? What's going to happen? I don't know. When a Japanese car company makes an announcement, we're not going to use this stuff anymore, they're not saying something they'd like to happen. They're worried that that might happen. So we're looking for new resources of the critical rare metals, and it's very, very important. I don't know if this is true, but in China I was told that the production of the heavy rare earths like dysprosium has now maximized, cannot increase production any further and still meet environmental safety, health standards. And not only that, it's believed by the people I talk to at the Chinese Society of Rare Earths that the deposits only at the current rate of production, 1,400 tons a year, have about anywhere, it depends who you talk to, at most a 30-year life. Now, China is the only place that the heavy rare earths, dysprosium and terbium, have ever been produced commercially, ever. So, right now, the rare earth market, the end user market, people who really need this stuff, not speculators or stock traders, don't know what to do about the future because businesses can't plan like that. You can't say, well, we'll make 125 million cars in 2017 if we can get the parts. That doesn't work. Again, here's a list of them. I'm sure everybody's got this. I was told as a young man, never show a periodic table in a presentation, so I always do. I'm a contrarian. Okay. Here's an easier one for you to understand. The element yttrium is most often associated with rare earth deposits, and in particular in those very few deposits that have high ratios of the heavy rare earths. Yttrium, to the best of my knowledge, is only produced today in the People's Republic of China, and it's in short supply. So here's what I said before. This is, I hear this all the time, this nonsense. Okay. It says here, most heavy rare earths are rarer than light rare earths and medium rare earths. I think it should say are always rarer, because really the most critically short metal is probably terbium today. The total world production in China is 200 tons. If you wonder why General Electric moved their lighting division to China, that's the reason. It's as simple as that. Not all heavy rare earths have been studied in depth. My partner, a boy of 40, named Gareth Hatch, is a PhD in magnetics from the University of Birmingham in the UK. And he was for 13 years manufacturing manager of a rare earth permanent magnet machiner in the States. We call that because they bought block material from China and machined it into magnets and then magnetized them. And he said to me, he keeps hearing from people who say they're going to make rare earth permanent magnets out of cerium. That's wonderful, that's a dream. And out of holmium. And the only problem is, how much holmium is there? Well, practically none, okay? So we joke in our company that if holmium turns out to be the world's greatest permanent magnet, it'll make a terrific thesis and a couple of research papers. There will be no commercialization. Growing economies in the world are very interested in being green. Green requires rare earths. Electric vehicles, I'm not saying there won't be any made, I'm just saying it won't be the percentage you think, and it doesn't matter in any case. Regular cars, fossil fueled, use rare earths, and the number of these cars is enormous. Okay. Wind turbines. Only 16% of wind turbines are rare earth permanent magnet types. The rest are using AC type motors. All right. what's the advantage of a rare earth based wind turbine? Less service. And if those of you who have stood at the base of a 300-foot high wind turbine tower understand that service is a problem. And very recently, Great Britain was going to put miles of these in the North Sea or in the Channel, and then the contractor showed them what it would cost to anchor them and service them, and this project seems to have gone away. Okay. They would have to be rare earth permanent magnet. There is no way you need to minimize service 300 feet above a hurricane or whatever the storm is called in the Channel. Now, this is rare earth demand by China and the rest of the world. But I want to be, my partner drew up this chart, and I want to explain it. It says here, rare earth demand in China is 67%. It depends on where in the value chain you stop talking and thinking. As far as I can tell, most of the rare earth metals are produced in China, and alloys. So I'm saying about 80% of the demand is within China. Now, if someone is shipping those metals and alloys to another country for processing into magnets or batteries, that's fine. But the real demand, overwhelmingly, at least 80%, to a saleable, profitable materials is in the People's Republic of China. That's today. Now, you notice the enormous difference in this distribution 5 years from now, 4 years from now. Things aren't changing very much is what I'm trying to point out. Remember, all of my charts and figures are based on projections given to me by companies that say they're going to do things. I'm not predicting anything, I'm projecting. There's the uses. And you can see that the largest use is permanent magnets. I'm not at all clear what metal alloys means on this chart, because neodymium iron, boron, samarium, these are alloys. I suspect that the actual magnet material demand is between 20 and 40%. I know that the world automotive industry, for which I'm the spokesman on this topic, uses 40% of the world's rare earth permanent magnets. That's why I keep emphasizing the automotive industry. All right. Permanent magnets and alloys are metals. They are not chemical compounds that come out of a separation plant. They have been further purified and processed. They are not what comes out of a separation plant. On the other hand, catalysts are also not coming out of a separation plant. But if a separation plant produces salts, soluble salts, they are used, at least lanthanum and cerium, to make zeolite-type catalysts for fluid cracking, which is a process of taking the heavier crudes and breaking them down into lighter fractions that can be processed. This is a big business. It was invented in the U.S., I believe. We have of the U.S. import of rare earths as raw materials, 95% is for the fluid cracking catalyst industry and consists of Chinese high purity rare earth oxides, which are transformed by American companies into chlorides, which are used to make zeolite compounds, which are in the catalyst. This is the biggest demand by a long shot. For some reason, people seem to think that the demand is magnets and batteries. It's catalyst, and it's of relatively available rare earths. The big problem for the U.S. industry, oil industry, was that if China were to reduce the export of this material as a raw material, the industry was very concerned. This was a big driver to produce some material outside of China. But keep in mind, the material to be produced is not metals, not alloys, it's salts, okay, which could be produced right here. This is what the plant here could easily do. I don't know what it produces. This is advancing this from 2011 to 16. Note that alloy and magnets have gone from 40% of market share to 42% of market share. This again is based on projections. I don't really know where these numbers come from, because if you can tell me what the weather is going to be tomorrow, I'll know if I need an umbrella. Nobody can tell me that, but they can tell me 5 years from now what the demand will be for neodymium. That's great. Okay, I believe you. Not really. Supply. This is where it gets interesting. This is today where the supply comes from. Okay? This means mining, not processing. Mining. Okay? Note that North America has 2 locations. In the United States, for some reason, we don't ever look below the equator. Brazil has been producing rare earths for a long time. Brazil has enormous deposits of rare earths, but Brazil has chosen a different path. It's become one of the world's largest iron suppliers. I've been down there to talk to them, and the first question was, what will this bring to our bottom line? And there was an answer given, and they said, we make that much in iron every 8 hours, so we don't want to do. Thank you. Thank you for your time. Enjoy the tourism. Now, you notice in the north, I think that the topmost pentagon is the Kola Peninsula of Siberia. That's a producing Russian mine which has been there forever, produces the mineral loperite. I'm not sure if anybody's processing it today outside of China. I don't know if, well, India's producing monazite from mineral sands. That's what's being processed in Kuala, I'm sure. Obviously in China is the overwhelming bulk of today's production. You can all, this chart is easy, you can memorize it, it doesn't take long. Okay. So here's where the stuff is coming from. The 2016 figure is based on everybody's projections coming true. Projections. As you can guess, I'm not a believer. So I'm going to say that China's going to go from 95% of world production today to maybe 80% or something in that period. But the dominance of China as a producer of rare earths is going to continue for some time. A great long time. This is a breakdown for a reason coming up of the various, some of the Chinese regions that produce rare earths. Please note that the territory of Inner Mongolia, which I believe is a Chinese state, produces 46,000 tons of rare earths a year. This is produced by dozens of companies, all under the aegis of Bao Steel, because it's the world's largest iron mining region. And what I want to point out to you, those of you who are waiting to call your broker, is that the gentlemen in Southern California say they're going to produce that much also in one mine with one plant complex, and they're going to produce the world's largest rare earth metals plant, the world's largest rare earth alloy plant, and even make magnets on the side. Okay? I believe it took China about 35 years to develop this capacity. It'll probably take the same time in California, or more. The U.S. Department of Energy has put this chart out. It was interesting because I drew this chart many years ago, and I was quite pleased to see it attributed to somebody else. And that was fine. That's how it goes. Notice what's in the upper right as the most critical material. The champion, by their thinking, even 15 years from now. Of the top materials, the most critical, which would shut down American industry if they weren't there, 1, 2, 3, G. All of them are rare earths or rare earth related, 100%. Would you like to know the most critical metal to American industry? It's called rhodium. 30 tons a year of production in the world. By law in the United States, an automobile cannot be built or sold without rhodium in the catalytic converter to moderate the nitrous oxides. So if they don't have rhodium at the car factory, they can't make cars. Total world production, 30 tons. This is considered to be the most critical metal to American industry. The only people who are not aware of it are the car makers. Now, Professor Yan, of course, will actually, who knows a lot about this, will speak about this. The rare earths are very similar to each other chemically. That's the problem. They're all found together for that reason. In nature, the separation processes that give us a gold deposit here or a cobalt nickel deposit there give us a rare earth deposit, because there's no process in nature that can occur in as short a time as 5 billion years can separate those rare earths. Okay, maybe in 100 billion years something would happen, I don't know. Now, interestingly enough, this is how rare earths report in nature. They're, for example, the ratio of praseodymium is a sister metal of neodymium, and very typically, because the cost of separating neodymium and praseodymium is so high, a commercial product called didymium was created, because it means I can't afford to separate them and still sell them for a profit. So now I have something called didymium. You can make magnets out of it. When we first made the magnets, we actually didn't know, we thought we had neodymium. We had all the rare earths. In fact, some people made mischmetal iron boron magnets, all the metals, because they didn't know how to separate them. All right. The point is, dysprosium ratio to praseodymium and neodymium in nature is from 1% of the rare earths in a deposit, in the best deposit, is dysprosium, to 1.5%. Now, the problem is, pardon me, 1 to 100 and 1 to 50. The problem is that the actual magnets, the ratio is between 1 to 2 and 1 to 50. In nature, the best deposits are 1 to 50, and the typical ones are 1 to 100. So the problem for magnets is we don't have enough of the heavy rare earth dysprosium. And nature is not helping in this case, because nature didn't invent the rare earth permanent magnet, humans did. Okay. This to me, this chart is again based on projections. I don't predict anything. If you look at the, in fact, IMCO is an Australian company that's been doing this kind of projecting for a long time. But what we did here is we looked at the projected demand in 2016 and the projected supply. Now, projected supply means that every rare earth miner who says, I'm going to produce X, we believe him. Okay? Most of these fellows would be excellent used car salesmen. Okay? So we believe it, you know, fine. So look at here, cerium, there's plenty of cerium. Neodymium is in balance. Europium is short, terbium is short, dysprosium is short, yttrium is short. That's based on, remember, this is an ideal situation. It means that every projection by every miner will come true. And the demand, quite frankly, is conservative. Okay. When we did this demand figure, the depression, which Americans call a recession, was in full bloom. Okay. It's over now, right? Now, this is just a discussion. The real issue in the entire issue of Chinese export quotas, which have been in place for 15 years, China's policy is very simple to understand. China wants to create jobs in China and profits in China. So, if you're producing something like the rare earths and you have learned how to process them and how to make them into end products, and people are saying, like Apple, well, we'd rather build our units in China than California because it's so much less expensive. What you do is you simply utilize your own raw materials for your own purposes. Now, when we do that in the United States, we call that good policy. When somebody else does it, we call it a threat to our well-being. Okay. No, I mean, you know, that's fine. I was drafted. I know how it works. Okay. And, you know, they didn't ask me if I wanted to do it. Okay. Now, the thing that you can all look at this if you want, but what we discovered in studying this was that although China reduced export quotas, she didn't reduce production quotas in China. And we understand what that's about, okay? The WTO case that was made recently, I'm trying to think of how to say this in a non-political way. Give me a second. I was very outspoken in this case, and I said, why did the United States do that? There was no point to it. The United States has very little demand for rare earths. Japan and the EU have huge demand. Japan is the world's second largest user of rare earths to produce commercial goods, and the Europeans get the rest. The Americas, let's say between them they have 100% of demand, and America has the balance. Now, why did America join in the WTO case? Nobody in Washington knows. Believe me, okay? It was politics, not reality. So, when I examine the issues, it looks to me like Chinese have all of the equities in this issue. So, the one thing these charts are showing, when all of this happened, there was a scramble for rare earths, and there was speculation, stockpiling, etc. The prices went crazy. What do you think was the first thing that happened in the automotive industry when that happened? My phone rang. They said, come in here and talk to us about the future price of neodymium. I said, why? I said, because we can't afford to use it if these prices are sustained. Okay? Guess what? I went and told all the miners, and I went to lots of meetings, and I said, keep raising the prices. Now I'm talking not, you know, the future miners club, the ones who are trying to develop. I said, now you're all recasting your business models to show huge amounts of revenue and profit because of these arbitrary prices. I said, guess what? You're going to kill the demand, destroy the demand. Then your stuff will be worth nothing. Okay, well, it turned out the market, as we say, corrected. And now, here's the interesting thing. Commodity prices work on an escalator. You can walk back and forth, but you're always going up, okay? So, the neodymium price, in my opinion, in the future will be under $100 a kilo. I don't even know where it is now, but I mean, I've seen it at $200, $300. That was not sustainable. I want to make a point. Dysprosium was over $2,000 in the non-Chinese market. Today it's about half of it. I think it's half of that in any case. But I personally do not believe, we have a speaker today who knows much more about this than I do, Mr. Neal, and I don't believe dysprosium will ever be less than $1,000 a kilo again, because I don't see it in surplus anytime in this decade. So there's a real demand issue, or demand will exceed supply. That's just a standard rule of economics. You can read all this stuff if you want. In case you haven't, this probably isn't the first thing you think about in the morning, the Chinese export quota issue. I personally, my own visits to China, the question asked of me is, what is this all about? And there's a cartoon here that exactly reflects, never mind him, Here, this one. This exactly reflects my experience with speaking to Chinese colleagues. 3 years ago, I got into I was listening, I didn't say anything, with a Chinese economist in Beijing in a meeting, and he said, why is it that when America does it, it's good, and we do it, it's bad? I don't know. Okay. So anyway, this is true. And the joke is, the ultimate joke is that the market is not in the U.S. Okay, we're really just gadflies in this deal. Oh, here's my partner came up with, I've actually read law. My partner came up with this. It's pretty good, but who cares? Now, at my company, Technology Metals Research, we have to have a metric. So here's what we did. Some of you may remember that in Indonesia about 10 years ago there was a little situation called BRIEX, where bluntly Canadian companies salted minerals and they thought there was a lot of gold, and they ran up a huge number on the stock market, and the whole thing blew up and a lot of people lost a lot of money. And the Canadian government decided they were going to set standards for banks, which means if somebody an institutional investor, I don't know, maybe a private investor too, wants to invest in a Canadian company, mining company, that company must meet all of the regulations written under Rule 43-101 of the Canadian Securities Code. And it's quite complicated, and everybody now follows it. Okay? So, in the world, they either use the Canadian system or the Australian JORC system, which is the same. It's a reporting requirement, verification of your deposit, verification that you have a technology to separate it. If you're going to offer material for sale in the market, you need to prove you can actually produce it. This is new, okay? Now, so, I don't know if I brought the slide. There are, at this minute, 36 companies that have met either 43101 or JORC in the world that we know of. These are obviously some of, not only these future suppliers, these are existing suppliers. Again, Buenanote and Mountain Pass are existing. All the Chinese are, actually everything on this is an existing supplier. Okay, now, these are people in various stages that may become suppliers. They're all 43101 compliant. Okay. Okay. So I don't want to go through here what all of these terms: inferred, indicated, measured. Let's just put it this way. The highest standard of proof is that you've actually, what would be the ultimate standard of measuring anything? An infinite number of measurements. So somebody's made a decision and you drill so many holes, you study the cores, you make a three-dimensional map, and when you've got enough of them done, your resource becomes more and more likely to be actually existent at that level. Okay, so if you look at the future supply, there are 400 deposits being actively looked at, some stage of development other than production, not production, in the world. The reason the chart on the right shows 54% Canada is because that's where 50% of the deposits are. Not that Canada's producing anything. To the best of my knowledge, there are no rare earths produced in Canada today. Okay, zero. But potentially, it could, 50%. Okay. Now let's see who else is in here. Greenland. That's not in the near term. Australia, actually, as you know, is producing at least ore concentrates at Mount Weld. USA is in here because we have quite a bit of rare earths, but we only have the one producing mine at this time, Molycorp, which I've been told is back in production. They've actually started mining. I'm not allowed to go there, I don't know, but I'm not. I have been to 2 other sites in the United States. One is in Wyoming, a place called Bear Lodge, which is moving towards, it's well into development. And another one is in Alaska. It's called Boken Mountain. It's a former uranium mine being worked up as a heavy rare earth mine. So the U.S. has 3 sites. One is actually producing. So if you wanted to make a graph, you'd say, well, 1/3 of all U.S. sites are in production. Fantastic, right? Yeah. No, that's how these charts are made, right? Statistics. So now, even more interesting is the breakdown on the bottom. This is the resources we're talking about, what they contain. Notice that the large part of the annulus on the bottom is cerium. Okay? The tiny little slits there on the top are dysprosium, terbium, etc. And that's the important stuff. Remember, no matter what anybody says to you, we don't really need much cerium. So right away, half of this pie goes away. Half of this annular chart goes away, ring chart. Future source supply. My partner devised this metric, and on the bottom axis is given the unit mass of the rare earth from the mine. This would be the dollar value in February 2012 if the materials in the ore concentrate were all supplied in velvet-lined mahogany boxes in hallmarked bars. That's what this would be the value. Okay? They usually present as dirt. Okay. Now this other one is something called the basket price, which I absolutely abhor. The basket price. You put them all together, and this is what it's worth, right? And you can assign any value you like to things like cerium, and that looks wonderful. But this chart is relatively correct. The value, for example, number 12 is Hastings in Australia. Anybody ever hear of that? Hastings is a wonderful heavy rare earth deposit, but it's just beginning. And the president of the company called me last week, and I said, where are you? He said, do you know where nowhere is? I said, yeah. He said, we're slightly east of there. It's a long way from anything. That's Hastings, but it's a good deposit. Okay. Now, the one I like, I'm just looking at the chart, then I'll look at the name. Okay. We have one here, which a high basket price and pretty good unit price here. Number 27, what is that? Norra Kärr. That's in Sweden. I visited that last September. That is the richest deposit of dysprosium, hard rock, that I ever saw in my life. The reason I'm saying hard rock, dysprosium today is produced in China almost entirely from called ionic clays, totally weathered systems where everything has been washed away except the rare earths are there. But here's the problem with the world's current only heavy rare earth resource. What is the actual grade of the material? It's something like 0.03%. So how do you process that? With enormous volumes of processing reactants. Enormous volumes. This is where you get the story of flooding the mountaintop and collecting the material in plastic-lined pools on the bottom. Okay, that's how it's done. I don't know if there are any hard rock, heavy rare earth rich deposits in China, but I do know there are about 8 of those deposits outside of China that are currently in development. The problem is they're too expensive to develop on their own unless they're extremely rich in the heavy rare earths and of a sufficient size to sustain production for a few years. I was at Norra Kärr in September. That's 6 months ago, 7 months ago. It was a farmhouse, a dirt road, and elderly farm couple. Okay? Now, what I'm saying is that's the state of development. That's it. However, there's no impediment to it being developed. It's a wonderful deposit. And the Swedish state has licensed it. They're all for it. It's really not near any particular habitation. And the deposit is so close to the surface that the rock I slipped on and fell on my face was actually ore. Okay? And luckily, there was a lot of grass there. So the young men around me thought the old boy's dead. It was comical. So as this will surprise you, without missing a syllable, I kept talking, stood up, brushed the grass off, and they were all looking horrified, like, is this a zombie? Okay? So, in any case, let's say, put it this way, I've been very close to Norishar, the deposit. And it's a very nice one. It has a processing problem. That's what we should be here to talk about today. Never mind looking for deposits. I'll give you a list of 400, it's on my website. We need to know how to process them economically. And this is the problem. We don't need all of the rare earths, we need the critical rare earths. We need a lot of neodymium. The largest deposit I know of in the world of neodymium that's going to be developed in your lifetime is probably Mount Weld. We used to joke 10 years ago. Actually, the gentleman who discovered Mount Weld is a friend of mine, and that was 33 years ago. He was working for Molycorp, the old Molycorp. They were charting the world's rare earths. And we used to joke that what's going to happen if Mount Weld goes in production? The neodymium price will crash, and that's the basis of the model. In those days, there was so little demand that there was no point to producing it. You would simply kill the price and ruin your business, the business. Okay. Things have changed. In my opinion, Mount Weld at full production, let's for argument's sake take 22,000 tons a year output from the lamp facility here in Malaysia. That would be 17%, which is less than 4,000 tons of neodymium. I think the world could use that material. I don't see a problem. The problem is one of business. No offense intended too much. Geologists are not businessmen. Businessmen have one simple rule in life. It has to sell for more than it costs. That's it. In America, we have a comedian named Guido Sarducci. He has the Guido Sarducci School of Business. He says, you gotta buy it for less and sell it for more. Now you get your degree. That's it. Okay. So I keep hearing about all these wonderful subsidies, and in other words, I pay for it, taxpayer. In the real world of business, the low-cost, most efficient producer wins every time. Okay. What I'm saying to you is that, contrary to what some people have said, I personally believe Linus is in the running to be the low-cost producer outside of China of these materials. And therefore, there's a big market. Now, if you think about that, let's use 4,000 tons, 4 million kilo at $100. That's $400 million of revenue. That's a lot of money. Because that plant, let's say, is running, I guarantee you that the fluid cracking catalyst end users in the United States, the three, BASF, Engelhard, American Unit, Albemarle, and W.R. Grace, would be delighted to get some of their 10,000 tons right from here, because they're looking for security of supply and alternate vendors, additional vendors. Okay. Sinopec is making these catalysts now. Petrobras is making. I was offered just a couple of weeks ago 25,000 tons of spent catalyst for recycling, 2% lanthanum. I said, the numbers don't work. He said, well, but lanthanum was $150 and lanthanum was $20. Okay, so it doesn't work. So what are we going to do with this stuff? We have a mountain of it. I said, plant trees on it. You know, make a mountain. Okay. Now, This is a big business. And here's a suggestion I'm going to throw out to the businessmen in the room. I just found out this morning, I've been told that the output of this lamp plant will be oxides or halide salts, something like that. I don't know. We'll find out tomorrow. Okay. I suggest that this plant be encouraged to get even larger and produce the finished high purity salts that the fluid cracking catalyst people use to make their catalyst. In the United States, 2 of our companies do it themselves, and one of them has a captive supplier, the only rare earth large-scale processor in the United States. It's in Houston. It's called Blue Line. They take Chinese high purity goods and they produce from them the salts used that Albemarle uses to make the catalyst. Here's the point I'm making. I've been a corporate executive, and if somebody comes in here and says we can outsource something, I want to hear about it. And what I'm saying is these fellows do not wish to make the stuff themselves. They prefer beating you down on the price and getting a little bit cheaper. So there's an opportunity here. Why doesn't somebody here go into the fluid cracking catalyst supply business? Sir? Is it going to light up again? Hey, great. Okay. So you've got to push the button every so often or the thing times out. In any case, that's a business. And that's a business you can do right here. Actually, you could make the catalyst here. That's not that hard. Notice how any mine listed on these charts is 43101 compliant. Therefore, it meets the criteria for investment by Canadian and other banks. I want to point out to you that as a percentage of contained neodymium, the world's leading deposit that we know of, at least outside of China, is Steenkampskraal in South Africa. The total rare earths to be produced at Steenkampskraal, 43101 compliant, are 35,000 tons in 14 years. So even though it's the richest deposit by grade, it's a very small deposit. Coming up next, Mount Weld, which may be one of the world's largest. I don't know how big the deposits are in China. I know the ones in Bayanova are immense. But let's say outside of China, Mount Weld is the next one, certainly the largest one in production anywhere on this planet. And it has a whole lot of neodymium. It's got a very bright future. Look at, that's interesting. You see, Molycorp's not on this chart. Think about that. Europium, I actually bought my first europium in 1967, working on red phosphors for displays. I thought I was getting it from Mountain Pass. I've been corrected. 40 years later, a friend of mine bought Steenkampskraal, the mine. And he called me. He said, you know what I found in the records? What? I said, you. He said, me? He said, yeah. He said, they were exporting ore to West Chicago, Illinois in the 60s, and you were a buyer of europium. I said, yeah, that's true. He said, well, it's in the record. I said, but that came from Mountain Pass. I said, no, it didn't. It came from South Africa. So, to the best of my knowledge, Mountain Pass has only produced europium in the modern period. That's what I'm saying. It's interesting. See, there was a global business back then. And I was around back then. That's true. Terbium, Mount Weld again. Steenkampskraal bringing up the rear. Next. Okay. This one. Steenkampskraal again. Mount Weld. You can see why people have been telling me the last 2 days, why am I against Linus? This is news to me. Look at how Linus appears on all these charts. It's an excellent source. Okay? Nora Shar is very high on this list. Yttrium, same list. All of them together, same list. Boring, isn't it? This chart was made for institutional investors. This is, what we tell bankers, so to speak, to look for. First, it has to be code compliant, or they can't invest in it without open risk. The government won't support them. Okay. Miners use the word metallurgy in a special way. They mean cracking ore. Those of us who actually are metallurgists don't mean that. So it's like talking in two languages to people. They say the metallurgy is settled. I say, so what about the separation? Oh, somebody can do that. No problem. Great. Okay? The metallurgy is actually quite complex for hard work deposits because miners only know of 2 or 3 reagents in the entire universe of chemistry. They know of 3 reagents: sulfuric acid, hydrochloric acid, and sodium hydroxide. That's it. So if it can't be cracked with those, it can't be done. Okay? And this is the difference between 50 years ago, 500 years ago, and now. Okay? The chemical engineers have not kept up with chemical technology. For those of you who are chemical engineers, I'm going to tell you something interesting. Trifluoroacetic acid is available in rail cars in Florida. It makes a wonderful extractant. Just mentioning them. The emphasized word here, this is the age of processing. That's the most important thing. We need to know how to crack or how to extract the mineral values and separate them from each other. The next, Dr. Yan's going to address that, the separation, current technology. My partner wrote, looking for metals and oxides, not 5 baggers. What that means is English, American slang. It means you don't want 5/9 material out of the ground. You just like to separate the stuff. You worry about the purification later. Security of supply has become an issue because of the limitation geographically of the supply and politically. Okay? The supply chain is truly capitalist in nature. It doesn't care about anything except money, profit. Simple. Okay? And unlike what they tell you in school, not everybody's going to be successful or good looking. It just doesn't work that way. You don't want any questions, correct? Okay. But in any case, look, what I'm telling you is that you don't need to think anymore about sources. It's processing. That's key. And what I should have said at the very beginning is this. If the Linus plant goes into production and ramps up to its projected numbers, Malaysia will become the world's 2nd largest source of finished rare earth goods. Number 1 will always be China. Number 2 is either going to be the United States or Malaysia. I've written a comment today somewhere else where I said every gram that a company like Molycorp ships to China for processing is not processed in the United States. Therefore, it looks to me like when LAMP is operational, Malaysia will be the world's 2nd largest source of rare earth separated products. That's the challenge here. And I don't mean to be disrespectful, but Malaysia can be a beacon for this industry or a backwater. It's entirely up to you. Thank you.